In this particular video now, we'll be treating the simple machine, the one that concerns an inclined plane. So if you missed our previous video, we are done with a pulley and a lever. So here we are tackling inclined plane. So what we need to know about the inclined plane also is the velocity ratio of an inclined plane. Remember, velocity ratio is distance moved by effort divided by distance moved by load. So from this diagram, this is what you call an inclined plane. An inclined plane. So from here, this load was actually at the ground level. The load, L, is actually here. So for you to drag it up to this point from here to here, any effort you are applying, so from here to here is distance moved by effort. So let's call it L. We can call it L, or we can just call it small e. The distance moved by effort from here to this point. So that height being covered from here, as you can see, from ground level to this point, is the distance moved by the load. From here to this point is the distance you are dragging it, you are applying your effort, which is E. So in the actual sense, from here to here, in a right angle triangle, first of all, we have that velocity ratio, which is distance moved by effort divided by distance moved by load. Now, the distance moved by the effort from O to B, so we can call it OB divided by distance moved by load, is this particular height it's covered from here to here, which is AB. So we have V, OB is E, while AB is H. So you can consider that way, or you can equally say, watch, distance moved by effort. Now if you watch this closely, OB stands for a hypotenuse of this right angle triangle. So if you are checking it in terms of the right angle triangle, OB is the hypotenuse. So our velocity ratio can also be written as the hypotenuse, which is hypotenuse divided by AB, which is the height, is the opposite, the side facing the angle theta. I hope you can see that. So we have opposite. Are you seeing what is going on? In the actual sense, in SOHCAHTOA, the trigonometric function or ratio that has opposite and hypotenuse is sine. Now sine theta is actually opposite over hypotenuse. Sine theta is opposite over hypotenuse. Therefore, if I want to get hypotenuse over opposite, what do I need to do? I don't need to take the reciprocal of this by inverting. Therefore, if sine theta is equal to opposite over hypotenuse, that means that 1 over sine theta will now be what? Hypotenuse over opposite. If sine theta is opposite over hypotenuse, then for me to get hypotenuse over sine theta means taking the reciprocal of sine theta, which is 1 over sine theta, that will give me hypotenuse over opposite. So instead of me now writing hypotenuse over opposite, I will simply replace this side with 1 over sine theta. So the velocity ratio becomes 1 over sine theta. Please note this, very, very important. So we have two formulas. If you are given the distance from here to this point, and from here to this point, depends on the question, and you're asked to get the velocity ratio of the inclined plane, you just need to divide this by this to get your velocity ratio. Or, most times, you will not be given this, you just be given the angle of inclination. It can be 45, 30, 65, 70. Just take the velocity ratio is equal to 1 over sine of that particular angle. You get your answer. So the velocity ratio is this. Velocity ratio is also this. So take note of these two formulas in block. The velocity ratio can be OB from here to here over AB or velocity ratio can be 1 over sine theta, not sine theta, but 1 over sine theta, as I have proven. Okay, we are going to solve a question here to illustrate this. Now we have an example to illustrate the inclined plane. Now what you have here, the example says the floor of a 911 vehicle is 5 meters high. A plank 8 meters long is used as an inclined plane. So in this case now, the plank serves as the inclined plane to raise some load up the lorry. If the efficiency of the machine here is the plank, if the efficiency of the machine is 50%, what is the maximum effort required to raise 250 Newton load up the plane? So if we have a lorry, and let's say solution, we have a plank. The plank is we have a lorry. If you have a lorry, you know how the height of the lorry. So for you to push something up, then we are told that you are going to cover a height of 5 meters. So we have, let's say here, from the ground level now to where you are going to enter. Here, we are told that it is 5 meters from here to this point. Now you now place a plank like this. We are told that the length of this plank, if the load from here, you are going to draw a load from the ground up. Then you now enter the lorry, inside the lorry this way. Now we are told that from here, the length of this plank, this is the plank, used as the inclined plane. So the length of this plank is 8 meters. From here to this point is 8 meters. So this is the height from the ground. Now, we are told that this load is 250 Newton. We are asked to calculate the effort. So how do we calculate the effort? We know, first of all, we need to get the velocity ratio. Why? Because efficiency is equal to mechanical advantage divided by velocity ratio times 100 over 1. So the only place we can see our effort is the mechanical advantage. So we need to get the mechanical advantage. Before we get that, we need to get velocity ratio. What is the velocity ratio of an inclined plane? In this particular question, the angle made with this plank made with the ground is not given. Therefore, we cannot make use of 1 over sine theta. We are making use of what? Distance moved by the effort, which is 8, over distance moved by the load, which is 5. So 8 divided by 5 will give us, 1.6. Remember, it has no unit. 1.6. Now, we have gotten the velocity ratio. I think we know our efficiency. Our efficiency, according to the question, is 50%. So we have 50% efficient. So 50%. Now let's clean this side. Now efficiency, which is mechanical advantage over velocity ratio times 100% over 1. I've told you, if you want to make use of if 50 direct, you have to maintain this. But if you are removing this to make it faster, you have to divide this by 100. So efficiency becomes 0.5. Yes, 50% is the same thing as saying 0.5. In that case, we just have mechanical advantage divided by velocity ratio, which is 1.6. We don't need to put this side again. Okay, so mechanical advantage becomes, if you cross multiply, we have 0.5 times 1.6. So 0.5 times 1.6 will give us 0.8. So 0.5 times 1.6 will give us 0.8. Now, can we now go and get our effort? Of course. So mechanical advantage, as we know, is equal to load over effort. Load over effort. What is our effort now? Effort is equal to load divided by mechanical advantage. So effort is load divided by mechanical advantage. The load in the question is 250 Newton divided by mechanical advantage. We have gotten that to be 0.8. So that maximum effort required is simply 250 divided by 0.8. So that will give us 312.5 Newton. 312.5 Newtons. Now, in this particular question, it is a little bit contradicting what we know about machines supposed to be helping. But as you can see, instead of us applying a small effort to overcome a bigger load, we are getting a bigger effort for a smaller load. So the effort this time around is bigger than the load. So who can tell us the reason why the effort is bigger than the load? But the actual sense is not supposed to be so. If you have your reason and you know your answer, drop it in the comment section. You will get a gift. If you give me a tangible reason why this is greater than this.